Actually, after Biopolis, I have been in EcoHealth Alliance, and then I was at the Federal University of Pará in Brazil until 1 month ago. And now I have just moved to the Université Libre de Bruxelles, well, where I am now based and speaking from Brussels now. And the studies I will be presenting today are indeed about the work that I carried out while I was at EcoHealth Alliance back in 2023. These studies are about the importance of the landscape, and in particular about the area of the landscape that is covered by indigenous lands on human health. And here I will be focusing on fire-related diseases and also zoonotic diseases. And I am bringing you two case studies, one from the whole Amazon biome, including all the 9 countries that encompass the biome, and another case study from the Brazilian Atlantic forest. And so this study was carried out in collaboration with the co-authors from all around these Amazonian countries. And as I was saying, it was carried out mostly when I was at EcoHealth Alliance working with Paula Priest. And I'll start by acknowledging the indigenous people and the importance of their lands. So indigenous people correspond to 6% of the global population today. And given their ancestral connection to their native lands, the way they manage and they use the resources is based on knowledge that has been accumulated over millennia. So it's a very special way of managing the resources based on that knowledge. And so it's not by chance that indigenous lands are characterized by lower deforestation rates and higher levels of biodiversity. And so here, what we were looking for was to really understand whether the benefits of indigenous lands could expand to human health as well, in addition to protecting the forests and the biodiversity. So from a previous study carried out by Paula Priest and collaborators, only focused on the Brazilian Atlantic forest part, Brazilian Amazon forest part of the biome. They found out that indigenous lands could avoid 15 million cases of fire-related diseases every year, saving something like $2 billion US dollars. And this was because indigenous lands are avoiding deforestation. So that means a lower amount of pollutants being released into the atmosphere and then inhalated by people. So similarly, it is also possible that indigenous lands are suppressing zoonotic disease spillover. So we know that zoonotic hosts are less abundant in areas that are less human disturbed. So here's just to illustrate that. And that is because of the dilution effect. So if we have a higher species diversity, in theory, the pathogenic agents would be more diluted through the species, and also because of co-evolutionary mechanisms. So if we have species that have been always in the forest where there's less people, in theory, they would carry a lower they will not be subject so much to these zoonotic agents. And this, together with the fact that indigenous management is based on this ecological traditional knowledge, we really think these indigenous lands can also have this mitigating impact on zoonotic disease incidence. And so to test our hypothesis, so here I am focusing on these two case studies. So the first on the Amazon biome, considering both the fire-related diseases and also the zoonotic diseases. And then the second case study focused on the Atlantic forest. But here we are just focusing on the zoonotic diseases, but at the individual level. And all data, meaning the health data and also the landscape data, have been collected and analyzed at the municipality level in both case studies. And in terms of the landscape variables, we extracted the extent of indigenous lands, so ITs, indigenous territories, across the municipalities. In terms of landscape composition, in the case study for the Amazon, we considered the forest cover outside the indigenous land, and this was because the indigenous lands in the Amazonia are already fully forest covered. And for the Atlantic forest, we considered the overall forest cover and the agriculture cover, the municipality. In terms of landscape configuration, we also extracted the number of forest patches and forest edge density. So these metrics are more about indicators of forest fragmentation. And then we applied generalized additive models accounting for geographic coordinates, year, and HDI, or the Gini index in the case of the Atlantic forest. Has smooth perimeters in the models. And so here we have the location of the Amazon biome encompassing all the 9 countries. And in this darker green, we have the indigenous territories that are legally recognized, and in brown, those that are not yet at least recognized. But for the purpose of this presentation, I'm just showing the results, including both, without distinguishing between them. And so here we have the patterns for the disease incidence. So at the country level, so here we have the fire-related diseases, including both the respiratory and cardiovascular diseases. And we can see that the disease incidence was the highest in Suriname. For the zoonotic diseases, including cutaneous and visceral leishmaniasis, Brazilian spotted fever, hantavirus, Chagas disease, and malaria, and that peaked in Venezuela. And so here are the results for the models. So we came up with 27 alternative models. So the best one was that including the extent of indigenous land that interacted with the forest outside the indigenous land, and then the edge density. And so here in this plot, we have a representation of the predictions made by this model. So the effects are quite complex and non-linear. So on the x-axis, we have the extent of indigenous land. On the y-axis, we have the fire-related disease incidence. And then each of the plots corresponds to a different scenario of forest fragmentation, going from low edge density to high edge density. And then the lines correspond to the amount of forest cover outside the indigenous land. So what we can see here is that when we go from a scenario of low to high fragmentation, there is a trend to increase the fire-related disease incidence. And then, so the instance, actually the only instance on which we can see that the extent of indigenous territories has a negative effect on the disease incidence is when forest cover outside is high. So in the other instances, that is either null or positive, the effect. When we go to the zoonotic disease incidence, so the best model was included the same predators, but in a slightly different way. So for instance, here, the interaction was between the forest outside the indigenous territories and edge density. And so here we have also a slightly different representation of the predictions of the model, since the model was also different. So on the x-axis, now we have the forest cover outside the indigenous lands. And here on the y-axis, we have the zoonotic disease incidence. Each panel here corresponds to a different level of indigenous land in the municipality, going from low to high. And then the lines correspond to the forest fragmentation scenario, so from low to high. And so here, there's not such a case where we can clearly see indigenous land minimizing disease incidence, but we can see a decline in the disease incidence as forest cover outside the indigenous land increases, and that is particularly when we are in the scenarios of medium to large edge density, so forest fragmentation. So we have this negative relationship here. When we go to the Brazilian Atlantic forest, well, the way the biome is covered by indigenous lands is a bit different. So it's the indigenous lands do not occupy such an area of land as it happens in the biome, in the Amazon biome. So you can see here in the map showing the Brazilian Atlantic forest biome. In this dark red, we have the indigenous lands, so they are not so widespread. And here we have the patterns of disease incidence for each of the 6 diseases considered. So again, we have Brazilian spotted fever, Chagas disease, hantavirus, cutaneous leishmaniasis, which was the most prevalent one, and then visceral leishmaniasis as well. And here, the data analysis was also a bit simpler in a way. And so what we can see here in these plots are the relationships between each individual zoonotic disease with the landscape predators. So in general, we can see that not always there's a significant relationship between the predator and the zoonotic disease incidence. There's also some differences between zoonotic diseases and their drivers. But in general, we can see that the indigenous lands tend to have a negative effect on the disease incidence. And that was observed for 4 out of the 5 diseases considered. And interestingly, in the case of the cutaneous leishmaniasis, which was the most prevalent zoonotic diseases in the Brazilian Atlantic forest, we considered the trend was exactly the opposite to that observed for forest cover, meaning that we think that some possible explanations could be that the way people are using the resources within indigenous land might be different. That might also result in eventually in a higher forest integrity within these lands, and also there might be a lower level of exposure. Explaining these results. So just to sum up, indigenous lands seem to indeed influence disease incidence, but in complex and non-linear ways. In the Amazon, indigenous lands allow to decrease fire-related disease incidence, particularly within municipalities with high forest cover outside the indigenous lands and low fragmentation. For the zoonotic disease incidence in the Amazon, that declined only when forest fragmentation was mid to high and forest cover outside was at least higher than 40%. But that was not so much the case when the indigenous lands were covering more than 75% of the municipality. So this is indeed a bit complex. Well, for the Brazilian Atlantic forest, the patterns were clearer. Eventually, well, at least in my opinion, maybe because there's not so much forest there, so maybe that allows to depict the relationships more easily. And indeed, their indigenous lands were associated with lower zoonotic disease incidence for most of the cases. Of course, there's several limitations to these studies. Most of them because of the coarse scale of analysis. So we could just have data at the municipality level. And of course, this did not allow us to come up with the mechanisms underlying these patterns. Of course, the different zoonotic diseases, fire-related diseases, they have different, well, for the zoonotic disease, they have different vectors. So different mechanisms might also be happening. And we recommend local scale studies to fill these gaps. But in any way, indigenous land Indians seem to have a critical role in human health, and this could be further expanded in more studies. Thank you very much. And these studies were funded by Ford Foundation. And you can check if you'd like to the full methods and results in the 2 publications. And yeah, thank you very much.